Okay, great. I think we have mostly one here. So again, hi everyone. Thanks for joining us for today's event, How to Effectively Automate Tests for Your Responsive Apps and Sites. My name is Adi and I'm the events moderator. First of all, I'm going to do another quick sound check. So if you can hear me okay, please use the raise your hand option in the control panel on your right. So show of hands if you can hear me okay. Wonderful. Okay, great. I see a lot of hands raised. Thank you. Okay, so today's speaker is Adam Karmi. He's the co-founder of Applitools and serves as its VP R&D, and he is a test automation expert. Just before Adam kicks off, a few important things to keep in mind. Feel free to ask questions during the webinar. You can do that in the GoToWebinar control panel on your right. You have a questions section over there. We will try to answer as many questions as possible at the Q&A session at the end. The webinar is recorded, and a link to the recording will be emailed to you tomorrow. For optimal viewing experience, I also recommend you close off any unnecessary apps running in the background. Also, if you encounter any technical issues, please send me a message in the chat room and I will try to help you as soon as possible. So now, Adam, the stage is yours.
Thank you, Adi. I hope you can hear me well. So hi everyone, and thank you for joining the webinar. And today we'll talk about how to effectively test your responsive applications and website, which is a topic that, at least in my experience, many mature and experienced test automation teams struggle with. Today's session is going to be somewhat advanced. We'll start by explaining what are responsive websites, and then we'll just jump straight into code. We'll implement a complete automated test from scratch for GitHub.com, which is a very popular responsive website, and that I'm sure that you all know. And during the session, we'll share a lot of best practices and tips, and of course there will be time at the end for Q&A. So what are responsive websites? If you look at the Wikipedia definition for responsive web design, you can see that it's an approach to web design that is aimed at crafting sites to provide an optimal viewing and interaction experience across a wide range of devices. But the best way to understand what it means is just looking at a responsive website. We'll look at GitHub.com and contrast the way it behaves, again, with respect to a non-responsive website, and we'll have wikipedia.org as an example. So let's start with GitHub.com. Right now we can see that we have a very wide screen viewpoint of that website, and you can see that it is laid out in an optimal way so that above the fold we have the main purpose of the website, which is to call out to people to sign up. And there is even room to fill in the sign-up details. We have a navigation bar at the top that allows us to quickly navigate and get to the other important pages on the website. And below the fold, we have the value proposition laid out in a single row of boxes that make use of the available horizontal space, and so on and so forth. Now, if I start to narrow the width of the browser, you can see that it actually the boxes begin to become smaller and smaller, and the images become smaller and smaller. And as you would imagine, unless something will change here, if I continue to do this, there won't be enough space for the text, and the images will be just small. But if I continue to narrow the width, you can see that at some point, actually the images became big again, and there's a lot of room for the text. And the website actually changed its layout to be optimal for this form factor, for this browser width. Okay, there are two columns now rather than one row. And at the top, although we still have the call to sign up and then the sign up form, there is no longer a navigation bar at the top because there's no room for it. Instead, it was replaced with a navigation menu that if we click it, it allows us access to all those pages just like we could with the navigation bar at the top. So if we continue to narrow the width of the browser, you can see that eventually we still have the call to sign up, but there is not enough room for the sign up details, so they are gone. And under that, the value boxes are now laid out in a single column because there's not enough horizontal space, but still everything is readable, the images are big, and the rest of the page is aligned in an optimal way. So just to conclude, a responsive website such as github.com would adapt its layout to any form factor whatsoever that you would throw at it. Okay, and it would show make the optimal use of the space available. Now, as an example of a non-responsive website, let's look at wikipedia.org, and let's look at the definition for responsive web design. And again, we start with a very wide screen, and we can see that the layout here is very nice and suitable for this type of a screen. We have the navigation panel on the left-hand side, we have some commercials on the right-hand side, but still the majority of space in the middle of the page is devoted to the term definition, which is the important thing, the content that people expect to read on their page. However, if we start to narrow the width of the browser, you can see that less and less space is available for the responsive web design definition, up to a point where there's no room at all, right, or very little room. On the other hand, the layout of the page did not change. We still have the navigation panel on the left, and the commercial is still the same size, but the most important part, the content of the definition itself, doesn't have any room. The reason for this is because the site is not responsive. It did not respond to the new size of the browser, and it retained its original layout. Now, in this case, if I continue to narrow it, there is also a very severe visual bug on that site, but this is a topic for a different discussion. Okay, so just like we saw with github.com, it also applies to many, many other responsive websites. That the primary page property that determines the layout mode of the application is the browser width. And the browser height is less important because people are used to scrolling down. So it usually does not affect the layout of the page, but the width does. And it's not really the width of the browser itself, it's actually the width of the viewport of the browser, which is the inner part of the browser window that actually shows the web page. And you can think of it as the browser width minus the borders on the sides of the browser window. Now, the value of this viewport width or inner width is available in JavaScript as the inner width property of the window object. And this value is also accessible to you within your Selenium test by using just a JavaScript call that will return that value if you need to use it in your tests. So we all know that every test consists of two parts. You have the interaction part that actually interacts with the application and provides inputs just like a user would. And then you have the validation part where you actually read the output the application produces and verify that it is as expected. So we are now going to start and implement just the interaction part of a test, and we'll add the validation later on. And in this example, I'll be using C#. I'll code with C#. I'll use NUnit to organize the tests and execute them, and I'll use Selenium to control the web browser. Now, the reason I chose C# for my example today is, first of all, because it's my favorite programming language, and I'm the presenter, so I get to choose. The second one is that there are not enough examples with C# and Selenium, so this is my small contribution. And the third one is that C# is very similar to Java, so I'm sure it will be easy for everyone to understand the code that I'm writing. So let's go ahead and just start building a test for github.com. We'll start by creating our test suite class. Let's call it GitHub test. I'll increase the font size. Okay, so we'll be using NUnit, so let's import the namespace. We'll also be using Selenium, so We'll use that namespace, and I would like to start with Chrome browser, so let's get that too. And now we'll mark our test as a test class as a test suite, so that would be a test fixture with an unit. And our test will be called test responsiveness. Test responsiveness, yeah, no titles there. Excellent. Now, what we would like to do is to have a web driver that will be available for us to control the browser. So let's define a field to hold that within our class. Before each test, as the setup routine, we would like to create an instance of that driver. We'll use a Chrome driver for now. And of course, at the end of each test, we would like to close it. Now, for now, within our test, let's just navigate to github.com and see that it works. Okay, so let's do driver.url equals https github.com. Okay, so let's run our test and see what we get. Here we go, Chrome starting, going to github.com, and we're done. So, okay, so first of all, we have a web driver browser starting, closing, and navigating to github.com. The next thing we want to do is add the ability to control different widths of the browser, right? Because we want to test its responsivity. So we would like to be able to pass in a parameters specifying the width from the outside. The way that we do it is that we add a field in our class to hold that width, and we add a constructor that will take the width from the configuration and set it in our field. And after we create our web driver, we can just set its width, and we'll just, for now, we'll just set the size of the browser window. Next, we'll see how we can do it and actually set the size of the inner width itself, which is what we actually want to do. Right? It will be more stable. So that would be driver manage window size equals, let's get the namespace using system going. We can do a new size, and the width will be width, and the height will be 600 outcoded because it doesn't affect the layout anyway. And for our test, what we'll do is that we'll start in the home page. Then we'll just click the personal button here to move to the personal page, and then we move to the open source page. That would be sufficient for the purpose of this webinar. So we would like to click this element so we can inspect it using the Chrome DevTools. And we can see that it has a class attribute, which is great, and it has a class name that we can use to locate it. That would be nav item personal. And so within our test, we can just call driver find element by class name and pass in that class and then click it. And this will move us to the personal page. And then we want to click the open source button from the personal page. So that would be, we can inspect it, and we see that it also has a class attribute, and it has a class name of nav item open source. So we can easily use it to locate this button as well. So driver find element by class name, and this is the one, and click it. So we can just run our test and see if it's working. Then again, we're not doing any validations right now. We're just simulating interactions, user interactions. So personal page, open source page, we're done. Very easy. Now let's try and run the same test on a different width, let's say 800 pixel wide, okay, and see what we get. We started, and test has failed. If we look at the output of the test, we can see that it failed at this line, finding this element, the personal navigation button, and we can see that the element is not visible. If we go back to our website and we start narrowing it to 800 pixel width, okay, which is about here, we can see that actually the personal button is not visible. It's actually hidden at this layout mode. And so this is why it's invisible and we cannot click it. WebDriver won't allow it. But we can see that we do have this menu button, right? And if we click it, then we can access the personal button here. If we look at the locator for that button, we can see that it does have a class attribute and exactly the same class name, nav item personal. This means that the different layout mode didn't really make that element go away. It just changed its visibility and position, so it would only be shown when you click the navigation menu, but it's still the same element. So what we can do is, instead of directly calling, finding the element and clicking it inside our test code, we can create a helper method that would see if it is required to first click the navigation menu button. So we can write this method, let's call it click navigation button. It will take a locator. And what it will do, it will find the navigation menu element. Let's see how we can locate it. So this guy also has this is the one, okay. We can see that it has also let me make it wider a bit, it would be easier to read. Okay, try again to find it. Okay, so this is the one. We can see that it has a class attribute and with the class name Opticon 3 bars. So we'll use that again to identify it. And what click navigation button will do is that it will look for this navigation menu button. Okay, we'll do it by class name. Pass in the class name for that element. And then we'll check if it is displayed. This means that the navigation buttons are not visible unless we click it. So let's do nav item click. And once we've done that, we know for sure that at this line, the navigation buttons are visible, so we can just click them. So we can do driver find element, pass in the locator that we have as input, and then click it. And now I can replace these two lines with a call to click nav button. Remove the click here. And do the same over here. And so, right now we can try and run the test on these two different layouts and see what we get. We'll actually have two tests now, right? One for each layout. So, we're starting it out. It's the first one that has the 1000 wide screen and it passed. It succeeded. And now with the 800 pixel wide, you can see that it first opens up the menu and then clicks the buttons, and both of the tests succeeded. No exception found there. So what we managed to do is actually build a generic test that can work for any layout of our application. I don't need to make any special adjustment within my test code to figure out how to interact with the page regardless of the layout that it has. Now, one thing that those of you who know their business can immediately identify that is bad with this test is that we're actually encoding the page details within the test code itself, which is bad because first of all, this is not very readable, and second, it means that if I have 1,000 tests and I just change the page, then I have to update 1,000 tests, What I would like to do is have a single place where I actually hide away all the implementation details of a page and just specify inside my test the user intentions so that if the page changes, I only need to update the page implementation. And for that, we have the page object design pattern. I'm not going to fully explain it right now. I assume that many of you know it, and you can also read about it if you don't know it. But what I'll do now is that I'll just paste some page objects here that can go over what I just pasted, and basically I will turn what we just did into, I will organize it into page objects without really adding any new functionality. And our page objects will all have a common base page because the pages have common functionality. And what I have here is that we have the three locators that I used before, the nav item personal, the nav item open source, and the Acticon 3 bars. I keep them as fields in this base class. The constructor will take a page name just for readability, the driver that we're using for this test, and also a callback that is called UI state change handler. Let's ignore it for now. When you get to the validation part, we'll see why it's useful. From all our pages, we can navigate to the other main pages of the website. So within our base page object, we know that the user can, one of the things that he wants to do is go to the personal page, in which case we just call click nav button, like we did before, providing the personal button locator, and then creating a new page object, which is the personal page. We can also, from any page, go to the open source page. Very similar, we can click the nav button for the open source locator and then create an open source page instance. The click nav button is implemented exactly the same way, finding the navigation menu if it is displayed, clicking it, and at the end clicking the required navigation button. The only change that we have here is that whenever we click the navigation button and open it, then we also invoke the callback that we had in the constructor and provide a description. In this case, that we just opened the navigation menu. Again, later on, we'll see how this is useful for us. Now, we have three concrete pages that extend or implement or inherit from the base page. They don't add any specific functionality, but of course, if there are any specific actions that we want to use in our tests, they would be inside each of the specific page objects. So the home page just passes in the name home, the personal page just passes the name personal, and the open source page passes open source. So it's a very simple change. And now that we have those page objects, I can rewrite my tests so that we start with the home page. We actually create the home page and provide it with a driver. I don't need to provide the callback at this point. Now I can go to the personal page by calling homepage.go to personal page, and then I can move to the open source page by calling personal page go to open source page. Right, so the test does exactly what it did before, only now it is more readable. It's very clear what I'm doing, and there are no implementation details in this test. Everything is encapsulated inside the page object, which is exactly what we did. And with this, we conclude our interaction code. And let's go over and review some of the decisions that we made during the implementation.
Adam, Adam, I'm sorry, yes, I'm jumping in. I just, some people mentioned that the sound quality is not so great. So if you could just speak a bit louder and a bit slower, so it will go over much better. Thank you.
Okay, I'll try. So one of the limitations that I have is because I'm writing code with both hands, I cannot hold the mic close to my face, but I'll try to speak slower and more clearly. Okay, so first of all, you should detect the page layout within the page objects. So different pages can have different layout modes and layout transition rules, and so the best place to encode those rules is within the page object that represent them and not inside your test code. Once you do that, you can implement generic tests that can interact with your responsive website in any of its layout modes and not having to update the tests when developers modify the layout transitions. Okay, just like we did before. Now, furthermore, you should avoid creating separate page objects for each layout mode, but rather have a single page object that represents all the layout modes of the page. I recommend this approach because, first of all, the different layouts, as I explained before, the different layouts of the same page usually share the same page elements and only change their visibility and their position and size on the page. So it's very easy to reuse the implementation inside a given page for all the layouts. And second, it also allows you to reduce the overall number of page objects that you need to create and maintain. And of course, this becomes critical if you have a site or application with many, many, many pages. Now, the next tips suggest that you should avoid detecting the layout using the window inner width property. As you've seen in the example test that we just wrote, I didn't address this property at all, but I could still detect the layout by looking at the navigation menu button, right? Checking if it is displayed or not. Now, although your application relies on this property to switch layout modes, and you can easily access it in your test code, if you rely on this property to detect the current layout, then your test will break whenever a developer changes the layout transition rules. So the preferred way is to detect the current layout by examining the state of the page elements, just like we did before. And now the last tip suggests that you should keep in mind that setting the browser width using Selenium sets the width of the browser window, which would result with a different window inner width value for different browsers and operating systems because of the different width of the browser window borders. And when we talk about validation, I will show you how to accurately set the browser width so you'll get a consistent inner width of the viewport. Now let's talk about validation. So we already know how to generically interact with the responsive website, but how can we make sure and validate that the sites actually provides an optimal viewing and interaction experience across a wide range of devices? And the answer to that is that you can use visual testing for that. And for those of you in the audience that are not familiar with automated visual testing, and first of all, there's a lot of material available online, but I will give a very, very quick and brief introductions just so you'll know what I'm talking about. So visual testing is a quality assurance activity aimed to verify that the graphical user interface appears correctly to the end user. It goes beyond what you used to do with tools like Selenium or Coded UI or Appium or UFT or the rest of them, where you basically check the functionality of the application through the UI. What automated visual testing allows you to do is to automatically verify that the UI itself appears correctly to the end user, that each UI element appears in the right color, shape, position, and size, that it doesn't overlap or hide any other UI element. And this is exactly what we want to test on a responsive website. It does show everything in the optimal way in each of its layout modes, right, and for each of its pages. Now here is an example of a visual bug that can easily be captured with automated visual testing. In this case, it's the Microsoft Azure Management Portal. You can see how the graph exceeded the expected bounds of the page. And this example is from Twitter. You can see how the notification text and timestamp overflowed on top of the notification below it. And in this case, from the Financial Times, you can see how the article title overflowed on top of the article body, right over here. Now, all automated visual testing tools work the same way. They have the same four-step workflow. In the first step, you drive the application under test and take screenshots. In the second step, the tool takes those screenshots and compares them with baseline images. Now, these images define the expected appearance of the application, and in the majority of cases, they're simply screenshots that were taken in the past and approved by a human tester. In the third step, the tool generates a report that includes all the screenshots, the baseline images, and any differences that were that were found, if any. And in the first step, the human tester has to look at the report and decide for each change whether it is a bug, in which case he opens a bug, or if it is a valid change to the application, he simply approves the new screenshot so it would be used as a baseline for subsequent run. And of course, the first time you run a test, you still don't have a baseline for it. So once you run the test for the first time, it creates the baseline automatically. It uses the screenshots that were taken and to set the baseline. And starting from the second run onwards, you always have a baseline to compare against. So let's just go ahead and add visual validation to our tests, to our test, and I'll be using Applitools Eyes to accomplish that. Now, the way that I integrate Applitools Eyes into our C# Selenium test is by using the Eyes C# SDK. And of course, there are SDKs for all the language bindings for Selenium and also for many, many other testing frameworks in all the popular programming languages, and also SDKs that work directly with images. So even if you have a custom framework, it would still can be added to it, and there are tools that work from the command line if you just gather screenshots on the file system. So there are many ways to do this integration. Now, the Eyes SDK will take care of two or three things for us. First of all, it will be able to set the browser width to the inner width that we just talked about. And if you're interested to see how that's done, just search for any of our SDKs. Just search for Applitools at github.com, and you'll find the code that does that. Okay, it's very, it's not a trivial code, but you can just copy it from there if you want to see, or read it if you want to see how it does that. The second thing that it does is that it captures screenshots from the WebDriver, and it is capable of simulating full-page screenshots for us. I'm sure that all of you that's been working with the Chrome driver know that if you ask it to give you a screenshot, it will only provide a screenshot of the viewport, but we would like to validate the layout of the entire page. So the SDK can actually take multiple screenshots while scrolling the page and provide us with a full-page screenshot. And the third thing that it's doing is that it actually takes those full-page screenshots and uploads them to the Eyes server, so where they're being validated. And if there is a problem, then it would fail your test, so it would appear as failed in Jenkins or whatever. So let's incorporate the Eyes SDK. First of all, we'll create a field to hold our Eyes object, which is the primary class for the Eyes SDK. So first of all, we need to add the namespace using Applitools, and now we have access to the Eyes class. Now, whenever we start a test, before each test, we want to create an instance of the Eyes class, and we need to also to pass in the URL for the server. Okay, in this case, it's the demo server. Then we need to pass in our API key that identifies the account that we are running against. In my case, I'm holding it inside an environment variable, so that would be demo API key. And as we said, we want to have full-page screenshots, even if the browser does not support it. So we'll do that by indicating that we want to force full-page screenshots. And the next thing we want to do is we are running multiple tests every time we run the test suite, so we want them to be grouped together as a single batch. So we'll just configure the Eyes SDK to batch those tests together. We'll have a static field here, type batch info, that will initialize. We'll call the batch responsive, and we'll set the batch to the Eyes object. Okay. Now, before the test starts, we want to indicate to the Eyes server that we are starting a new test, and the way that we do it is that we call Eyes open. We pass in the driver. This is how we can actually get the screenshots from it. We pass in an application name. I'll use GitHub. And the test name, which with NUnit is available through the test context, the current context test name. And the last parameter is the viewport size. And what this will do is actually set the size and width and height of the viewport rather than the browser window, which means that it is consistent across all the different browsers and all the different operating systems and the operating system configurations. So we don't need to set it through the driver manage anymore. We just pass it in, pass the size to Eyes Open, and it will take care of setting this size for us. At the end of each test, okay, we would like to make sure that the test closes, or if an exception is thrown during the test, that it is marked as aborted. So we will call Eyes abort if not closed. And now that we have everything set up, we can just add visual validation points to our tests. And it is something that is very, very easy to do. So after we visit the home page, we want to check that entire page. So all we need to do is call Eyes check window and provide an optional description. In this case, I'll just add homepage.name. So with this single line of code, we just have added 100% coverage for the home page. We're actually done for that page. We saved ourselves the trouble of writing thousands of equivalent lines of code, of finding elements, locating them, preparing expected data, writing assertions, maintaining these as the page changes in the future. With this one line of code, we are just done with this page. Similarly, after moving to the personal page, we can just call Eyes check window for the personal page with the name as the description. And after we go to the open source page, we can just do another check window and just pass in the name of the open source page. And basically, we're done. At the end of the test, we want to tell Eyes that we actually finished the test. Okay? So if we successfully execute the entire test as far as Selenium is concerned, there are no changes to the page that make some elements go away, then we'll call Eyes close, which means that the test will close successfully. If an exception will be thrown somewhere here because the implementation of the test was changed and Selenium cannot find an element or something like that, then an exception will be thrown and the test will be marked as aborted in the third line. Now, the only thing that's left for us to do before we run the test is to figure out one thing that is interesting and that we didn't yet think of, is that when we are actually validating this test in a layout mode that doesn't show the navigation bar, then as you remember, probably remember from before, we first have to open up the menu and then click this link. But we would still want to validate this state of the page where the menu is open, right? Because we might have some visual problems here on this state of the UI where the menu is open. Maybe an element is missing, maybe the buttons are not aligned, or any other difference that is interesting to us. But our test is generic. It doesn't care about the layout. So how can we add a layout-specific validation point to our test and still keep it generic? The answer is the callback that we just had in our page object. So if you recall, our page object takes the UI state change handler callback. It's just a signature of a method that takes the string. Okay, that's it. And we saw that the page object invokes this callback whenever it clicks the navigation menu, only if it does that. So this could be a point where we can actually register a callback method and pass it in that would take the description and then just call Eyes check window with that description. And this means that if we are in a layout mode that actually goes through this interim step, then this callback will be called and it will add that checkpoint to the flow of our test. So we have a generic test that can still perform layout-specific validation points. Okay, we'll talk about this a bit later on when we'll review what we just did. But let's run this test and see what we get. Okay, so this is the first resize, 1000 pixel wide. You can see the page scrolling. This is the SDK stitching a full page screenshot, moving to the personal page, then to the open source page, and the test is done. And now with the 800 pixel wide browser, taking a full page screenshot, opening the menu, full page screenshot, moving to the personal page, again opening up the menu, full page screenshot, moving to the open source page, and we are done. And the two tests have passed because we already had a baseline and there were no differences detected. And if we refresh the list of tests, we can see that we have a new batch. It is called responsive. It's green because the test passed. We can see that we have two tests here for the GitHub application, one with a viewport of 1000 over 600 pixels and one with 800 over 600. If we drill down to it, you can see that we have a timeline at the bottom showing us the 3 validation points for the 1000 pixel wide test. But for the 600, for the 800 pixel wide test, it's exactly the same code, only it produced 5 validation points because of those interim steps. If we look at step 2, okay, you can see the step of the menu. We can also play back our test and see exactly what it did. So we click the menu, then the personal item button, another time the menu, then the open source button, and then it moves to the open source page. Now, each of these validation points actually consists of 2 images. We have the baseline image that dictates how it's supposed to look like, and the current image which shows you what actually was captured in this test time. Now, just to show you that it's not just a fancy report and you do have 100% coverage, let's simulate a change on that page and rerun the test and see if the tool captures it. So the way that we're going to do it is that we are going to basically find this GitHub icon and make it go away, just hide it. It's easy to locate it. It also has a class attribute with the optical mark GitHub as the class name. And what we'll do that in our page object, whenever we go to the personal page, we'll go there and then we'll inject some JavaScript that will basically find the element of the icon and make it hidden. Okay, so let's run the test and see what we get now that we have injected this change. Okay, you can see that in the personal page, the GitHub icon is missing. It doesn't appear next to the personal page. And it reappears for the open source page. Now let's let it finish for the 800 pixel wide layout. And we're done, and both tests have failed as we expected. If we look at our dashboard, you can see that we have a new run of the responsive fetch. It has 2 tests that have failed. And if we look at the thumbprints of those pages, we can see that for the 2 occurrences of the personal page, we have a difference here at the top. And indeed, you can see that the GitHub logo is missing. So any other change that would appear on that page would actually trigger this. So you do have 100% coverage for that page, as I said before. So if we had a little bit more time, we could have written a few more validation points and run the test on a few more browsers. Eventually, we would end up with something that looks like this, where we have our, oh, it's not that one, it's a GitHub one, where we have many tests running on different browsers and different devices with screen resolutions, etc. And we might have, for removing the GitHub logo, we might end up with many, many differences. Now, although it is very easy to check the difference up close and see it and make sure that it did what we wanted to and accept or reject it immediately from here or even from the thumbprint itself, again, there could be situations that you could have many of these failures and it could be a bit overwhelming to go over all of them. So what you can do is ask the tool to actually group those changes together so you would only see unique changes. And once that's done, you can see that there are only 2 images you need to look at. If you look at the first one, you can see that indeed the logo is gone, like this is what we intended to do, and we can just accept all these differences at once. And we can look at the second one and see that in this case, the logo didn't go away. It actually changed color to green, so this is not what we intended to do, so we can just reject it and just save the entire batch without having to make the same decision and look at the same difference again and again and again in all different tests. So features like this one that are called automated maintenance go a long way in allowing you to scale up your test without really increasing the amount of maintenance overhead. And of course, everyone in the team, even people who don't know how to program, can perform this type of maintenance. And we do have customers today that are running thousands and even tens of thousands of tests every day, and with very minimal maintenance of it. So let's go ahead and review some of the validation tips that we went over in this test. So first of all, the first tip is to always prefer full page validation when possible. The reason is that first of all, you get much more coverage, but second, you also get less maintenance to do, because if you do full page validation, you don't need to take care of identifying the individual elements on the page and locating, maintaining those locators for those elements as the page changes. Just visiting the page covers everything with less code to write and maintain. Second, you should use a page object callbacks to validate layout-specific UI states, just like we did in our example. We had layouts that passed through interim UI states to accomplish certain functions, and they used the page object, notified the test that it just changed the UI test using that callback, and so we could maintain a generic test that can validate and have different number of validation points depending on the layout itself. Third, you should focus on lower layout boundaries, and this is a very important tip. Basically, whenever you have a range of values in every given test, a good way to choose values that would catch bugs is to go for the boundary values, right? Because this corresponds probably to conditionals in the application code, and that's places where developers can go wrong. When it comes to layout, responsive website testing and layout testing, it makes sense to always include the lower boundary values. And the reason is that these lower values represent the worst and most challenging and most crowded and dense appearances of each layout mode. And because of that, this is the places where you could expect elements to overlap each other and overflow. And just to show you this is something that is very, very real, if we look at github.com and we look at the exact place where it switches to a wider layout mode, exactly here, you can see this visual bug, right? If I just pull it up a few more pixels, it's okay. But right here at the boundary, they have actually a visual bug because in this layout, on its minimal transition point, they do have a layout problem. Okay, so this is a very important tip that you should, I recommend that you use. Now, you also don't want to abort your test on validation failures. The reason is that because once you complete your entire test, you already have all the images that you need to approve without rerunning the test. And also all the automated maintenance features and groupings and all of that will be available to you. Lastly, in terms of deciding between running on emulators or devices or real browsers versus headless browsers, then when it comes to browsers and responsive website testing, always go for real browsers. The headless browsers do not indicate how real browsers show the layout and exactly how the page is displayed. They are limited to the specific browsers that they support, like Safari and Firefox, and you don't have good coverage, for instance, with IE. Now, Chrome driver has a headless version, so you do have coverage for Chrome today, but still you rely on an old layout browser engine version, so it might be that with the headless browser things will look right, but with the newest Chrome version that just came out 2 days ago, you have a visual bug, but you won't find out about it because you're using an older version that's available with the headless browser. And when it comes to real devices, then they are harder to combine, they are more expensive, of course, and harder to automate. So there's nothing wrong with testing against emulators and simulators, but because these do not really simulate exactly or emulate exactly how things are shown on a real device, especially when it comes to OEM additions that affect the viewport size, then you should also in addition to those emulated tests, try to run tests on real devices, at least on the popular devices that you're targeting, just to make sure that it does look right on these real devices. And with this, I conclude the sessions, and I'll be happy to take any questions that you have. Adi?
Yes, sorry, I was on mute. Can you hear me?
Yeah. Yes,
Great.
I can hear you well.
Okay, great. So first question, we have a lot of them, by the way, and we'll try to get as many as we can. We got a lot of questions about marquee elements and auto sliders, and I'll just take a question that sums it up. Can I just validate some part of the UI if I have a marquee kind of images which slide in and out?
Yes, definitely. So first of all, there are many ways to deal with those. The first one is to mark an area of the page to be ignored. If something is moving around, you can also mark it as a moving element or a floating element and define the area in which it is moving, so we'll get validation for that as well. The third option is actually to make your site or application more testable by allowing you to specify, for instance, in the URL or in any other kind of backdoor, the exact position of the slider that you want to be fixed, and then if you specify that, you always have the same image, and you can then even validate it in a stable way.
Another question that we got is about the Applitools Eyes algorithm, and one of the questions, what algorithms are we using to compare images with eyes? Is it some type of bitwise comparison or advanced algorithm?
Yeah. Okay. So we have other webinars and a lot of presentations that I gave on YouTube that go into detail around this. So basically, what's special about Applitools is its image processing algorithms that we've developed as a team of experts for many, many years, and we continue to refine and build new ones. I don't want to go into too much depth about it, but we can compare extremely dynamic pages by their layout, and Our algorithms don't rely on any thresholding, and they emulate the human vision in the way that it only highlights differences that are visible to the human eye. And you can find a lot of material about that on the web, in YouTube. Check out the last Selenium conference. You'll find a talk that I gave on this subject there. So definitely advanced algorithms, and it works very stable and can really scale. You can scale your test to thousands of tests on a daily basis and with no problem.
Great. Another question, can testing with Applitools Eyes be done on different host machines which might render images differently?
Yes, definitely. So this is what's special about our algorithms, that they are very capable at detecting all those differences that are basically severe but still not visible to the human eye, such as anti-aliasing, image scaling differences, shadows, gradients, a position of elements that are different as determined by the browser layout engine, columns of tables that get to be 1 pixel wide and move the rest of the images, and et cetera, et cetera. Definitely, yes.
Wonderful. How does Applitools Eyes handle screen resolution changes?
So basically, the default behavior is that just like I showed you now, I use the same code to run on 2 different screen resolutions, meaning the size of the viewport. And it automatically created 2 different baselines for these 2 environments. Similarly, if you would change browser, if you would change operating system, then a new baseline will be created to each of these environments because they actually render differently. It is also possible to perform cross-device and cross-browser a test, but then you need, within the SDK, within the Eyes object, indicate that you want to compare against a different baseline. But the important part of the answer is that you don't have to do anything special in your test, and the appropriate baseline will be created and matched against, depending on the environment that you're running the test. And that's all and it will just work as you would expect it to.
Okay, I got quite a few questions about integration of Eyes with languages such as Protractor and Java and PHP, as well as some third-party providers. People mentioned Sauce Labs. So Adam, maybe you could just elaborate for shortly about those types of integration and what is possible.
Yeah, sure. So we have close to 30 different SDKs today that are constantly maintained. We cover Selenium SDKs in all the language bindings. We have SDKs that, and they also support Appium in all the languages. We have specific SDKs for coded UI, UFT, LeanFT, Protractor in JavaScript, and many others that work just with images, and as well as command line tools that can take images from the file system and build tests out of them. They can compare PDF files. So there are plenty and plenty of options that can be used for testing. Specifically for Selenium, the Selenium SDKs, as I shown you in the code, all they take is a WebDriver. So the Eyes SDK for Selenium, when you call Eyes Open, takes that driver. So, and it doesn't care what kind of driver it is. So for instance, if you're running your test on Sauce Labs, so this would be a remote WebDriver pointing to Sauce, it would still work exactly the same. So we don't care what browser it is or where it is running locally on the machine, on your local grid, or our remote grid like Sauce Labs grid. So it doesn't matter really for the SDK, it would work just the same.
Okay, and one last question since we are out of time. How does Applitools handle dynamic content or change in color?
Okay, so we do have, in terms of changing color, we do have a match level that ignores color changes. So if that's the problem, then this would help you. You can also check specific regions by ignoring color. And in terms of dynamic content, you could either, if it's just a small part of the screen that you want to ignore, then you can just mark it as an ignore region. If it's something that's moving, you can mark it as a floating region. But if it's a very dynamic page like a Twitter feed or yahoo.com, then you can use structural matching, layout matching as we call it, where basically the algorithm decomposes the image into its structure, columns, paragraphs, strings, inner images, etc., and it compares those structures. So even if you have very dynamic text or images or whatever, it would be able to compare and match it, and there's a lot of material on the web that you can see exactly what I'm talking about.
Okay, so this is all the time we have for today. Adam, thank you very much for this excellent webinar. I wanted to mention that all the questions that were asked will be answered via email, and the recording will be sent out tomorrow. So again, Adam, thank you for this webinar, and thank you for everyone for joining us. Bye. Hope to see you in our next event. Bye.